Hello friends and welcome to another tutorial on Geeks4Geeks. In this video, we are going to understand the program which helps us in converting a binary tree into its mirror tree. First, let us understand what exactly mirror of a binary tree means. Mirror of a binary tree is another binary tree with left and right children of all non-leaf nodes interchanged. Now, let us see the algorithm which will assist us in converting a binary tree into its mirror tree. Let us also have a sample tree to test our algorithm. We first pass the root node which is 1 to function mirror. Hence, node will point to 1. Since node is not null, we enter the else part. Now, we have another variable temp which will be used for swapping. Now, we recursively call the left subtree. First, the left child of 1, which is 3, is passed. Since node is not null, we move to the else part. Now, we pass the left child of 3, which is null. Since node is null, we return to the call stack. Now, we move to the right subtree of node 3. Since it is also null, we again pass null. Next, since node is null, we return to the call stack. Since the left and right child of node 3 is null, nothing is swapped. We complete code for node 3. Now, we move to the right subtree of node 1. First, 2 will be passed in node. Since 2 is not null, we enter the else part. Again, we call the left subtree of 2, which is node 5. As you can see, node now points to node 5. Now we pass the left subtree of node 5. The left subtree of node 5 is null, so null is passed. Since node is null, we return to the call stack. Now we move to the right subtree of node 5. Since right subtree of node 5 is also null, we pass null in function mirror. Since node is null, we return to the call stack. Now, we will swap the left and right child of node 5. Since both are null, nothing is swapped. We continue execution for node 2. Now, we pass the right child of node 2, which is 4. So, node will now point to 4. Again, since 4 is not null, we enter the else part. Now, we pass the left child of 4, which is null. Since node is null, we return to the call stack. Now we move on to the right subtree of node 4, which is also null. Since node is again null, we return to the call stack. Again, we swap the left and right child of node 4. Since both are null, nothing is changed. Now, we continue execution for node 2. After traversing the left and the right subtree of node 2, we swap the left and the right children of node 2. We will use the temp variable for this. First, temp will point to 2's left, which is 5. Next, 2's left will be equal to 2's right. So, the left child, which is 5, will now be equal to 4. Now, 2's right child will be equal to temp, which is 5. We finish execution for node 2. We continue with node 1. We will swap node 3 and node 2. First, temp will point to the left child, which is 3. Now, 1's left will be equal to 1's right. So, in place of 3, we will have node 2 along with its children. Now, 1's right will be equal to temp. So, 2 will be replaced by 3. With this, we have the final mirror tree as our output. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in our tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.